Hi again, everyone. So how are you going? For chapter 6F, we're doing the volume of prisms and cylinders. So the volume of prism, to find the volume of the prism, for example, in the question below, which has the dimension of 2 by 5 by 7, the volume will be the area of the base times the perpendicular height. So normally in your textbook or in your formula sheet, you might see V equals AH. So capital V is actually, it stands for volume, A stands for the area of the base, and H stands for the perpendicular height. So all you have to do is times 5 by 7, so that's the area of the base, and times by 2, you will get the volume of a rectangular prism. So, and of course, the unit is centimeter cube, because that's for volume. Yeah. Previously, we have calculated the total surface area, and yeah, just a reminder that for that, the unit is centimeter square. So how do we find the volume of an oblique prism, like for example below? Well, it's the same thing. The volume will be the area of the base times the perpendicular height. Perpendicular means that it's the height that makes a 90-degree angle with the horizontal line. So this is like the vertical height here. Yeah. So again, we're using the same formula. V equals AH. So the area of my base will be 2 times 3 times by my perpendicular height. I have 48 centimeter cube. So this is actually the volume of the cylinder. So how do I find the volume of the cylinder below? It's the same thing as well. So the volume will equal to the area of base times the perpendicular height. So in this case, the area of my base is actually pi r squared, because this is a circle, times by the height, which is 10. So it's going to be 490 pi centimeter cube. Sometimes cylinders are not arranged in this way. It might be like flat on the other side, but as long as you can identify the cross-sectional area and times it with the height, you will get the volume of a cylinder. So what if we have a trapezoidal prism, like for example below, and it's sort of like flat on the surface? So yes, the first thing we have to do is we have to identify the cross-sectional area. In this case, it's this trapezium face that's facing the front over here. So what we can do is volume will be the cross-sectional area. So that will be the area of the trapezium here times by the depth. So this is sort of like the height as well, because if you actually stand this up and make the trapezium the base, this will be sort of like the height. So we are actually doing the same thing. It's just that we tweak the formula a bit. So the area of the trapezium will be the two parallel sides added together, which is 2 plus 8 added together, divided by 2. So that's part of the formula, times 4. So that's for the trapezium, and times by 5, which is the depth, and we get 100 centimeters cube for the volume of this prism. So what if it's a composite solid? So does this shape look familiar? Yes, we have done this shape for the total surface area, and now we are focused on finding the volume of this composite solid. Yeah. So we know that this composite solid comprises of a rectangular prism as below and a cylinder on top. To find the volume of the rectangular prism, as what we have done before, we have to use 5 times 7 times 2, which is 70 centimeter cube. To get the volume of the cylinder, it's going to be pi r squared times 3. This is what we have done just previously. So pi 1 squared times 3 will give us 3 pi centimeter cube. So adding these two shapes together will give us the total volume of the composite solids. So I hope that you can do more exercises for this. And until we see again, see you next time.